Okay, so this is support to help you with FRQ 5. So it's telling us that train A runs back and forth on east-west section of railroad track. Train's A velocity, measured in meters per minute, is given by some sort of differentiable function where time is measured in minutes. Selected values are given in the table above. So this information up here is specifically for train A, and it's the velocity information. And then a second train, so there is a second train, train B, that travels north from the origin station. At time t, the velocity of train B is given by this equation here. So train B has an actual function, whereas train A is given in a table of values. Okay, so for question A, they want us to estimate the acceleration of train A at t equals 6. So if I take a look at t equals 6, it's not given above, right? So when I'm looking at that table up here, I know that t equals 6 is somewhere between 5 and 8. And so if I want to estimate that acceleration at 6, or let me, that's fine. So then I'm going to be looking at somehow the change in velocity over the change in time, right? So acceleration is the, oops, and I'm estimating, so a couple wiggles there. So I need to find the change of velocity over the change in time. So I just need to subtract, right? So like f of b minus f of a over b minus a, like that's essentially what equation I'm using. So for this particular problem, since I'm looking at t equals 6, then what I want to take a look at specifically, since t equals 6 is somewhere between 5 and 8, I'm going to be using these data points right here, okay? So then I would have a of 6 is about equal to, so the change of velocity, so I'm going to subtract these guys right here. So negative 120 minus 40, and then all over b minus a, so 8 minus 5. And again, I could do the arithmetic. I can leave it like this. It really doesn't matter. I'm going to go ahead and leave it like this because I know I'm not going to need this. If I did need it further on, maybe I would try to simplify it, but this would be all I would have to do. And then the other piece I need to pay attention to is they asked me to indicate units of measure. And so in this particular, I have meters per minute and minutes. So I know that my numerator is meters per minute, right? And then I'm dividing by minutes. So meters, so then that would be meters, right, per minute, and then squared. Okay? All right, and then now for part B. So for part B, what they're asking for is they want train B's acceleration at t equals 6. So train B's acceleration. So I was given this velocity equation for train B. So I'm not actually approximating it. I'm finding it exactly. And so what I know is when I take the derivative of velocity, that's going to give me acceleration. So the derivative of velocity is acceleration. So that's what I need to do, is I need to find the derivative of velocity. Okay. Had to let my dog out. Okay, so let me go ahead and do that now. So in this particular problem, I know that v of t for train B is given as negative 5t squared plus 60t plus 25. So then acceleration will be that derivative. So that would be negative 10t plus 60. And then I'm at t equals 6. So then I'm going to replace t with 6. So then that would be negative 10 times 6 and then plus 60. So again, I could simplify if I wanted to, but that would just be equal to 0. So there is my acceleration. So velocity would be constant at that particular point, right? Because there's no acceleration. Okay, so let's take a look at part C. So now for part C, I have at time t equals 2, the train's position, train A's position is 300 meters, and it's moving east. Write an expression involving an integral, so integral, that gives the position of train A in meters from the origin station at time t equals 12. And then use a trapezoidal sum. So we're going to do a trapezoidal sum with 3 subintervals indicated by the table to approximate the position at time t equals 12. Okay, so I know a couple of things, so I'm going to kind of summarize what I know right now. So at time t equals 2, the position is 300. And then I need to write an integral that gives position. So I know the integral formula for position, right, is initial position. So like, where did it start? So we would write that as like something like x sub a, and then plus the change in position. So the change in position, meaning the integral of velocity, right? And so this is my initial position, right? And then this is my change in position. Okay, so that's just a couple of little reminders there. And then we're looking to do this with a trapezoidal sum. So a little reminder on trapezoidal sum. So trapezoids. Approximations are when we add up, right, our y values and divide by 2, so we average them, and then we multiply by delta x. So that was a trapezoid approximation. So we add up our y values, divided by 2, and then multiply by delta x, right? So those are all kind of just little review ideas here before we actually do this problem. So let's go ahead and do this one now. Okay, so the first thing they asked us to do is write that integral expression. So we're going to go ahead and do that. So this is just reminder stuff up above. So here's the actual work. So my position, right, an integral gives a position of train A at time t equals 12. Okay, so my position would be equal to my initial position, which was 300 meters, right? And then plus the change, so 300 meters, plus the change in position, so that was at t equals 2. And then we are going until we get to t equals 12 of the change in position. So that would be v of a of t, because we don't actually have an equation, so it would look something like that, okay? So that would be the integral that we would have. And then now they want us to approximate that using a trapezoidal sum. So then the position would be now about equal to 300 plus, and so now what we have to do is we have to take the trapezoid approximation to approximate that. So we're just going to go from 2 to 12. So we need to make sure that we're paying attention that we're only going from 2 to 12. Okay, so from 2 to 12. Okay, so then I'm going to do average, right? So we're going to take 140. So we're going to take those first two values and we're going to add them and divide by 2. So that would be 100 plus 40 divided by 2, and then I want to multiply that by delta x. So when I go to find my delta x, I'm going to take the difference between 2 and 5, which is 3, so times 3. And then I'm going to do that same thing again, and then this time I'm going to go ahead and I'm going to take a look at the next set of values, so from 5 to 8, so that would be, now I'm going to use these two values, and I'm going to add them and divide by 2. So when I add that and divide by 2, I would get 40 plus negative 120 divided by 2, and then times delta x. So in this case, my delta x goes from 5 to 8, And so that would be a difference of 3, so delta x would be 3. And then I'm going to go to my last set of values here. So now I'm going to go and use the last set from 8 to 12. So then those two y values are 120 and 150. So I'm going to add those. Divided by 2, and then that delta x is going from 8 to 12, so that would be times 4. And then I don't need to simplify that at all. I can leave it just like that. Okay, and then that would give me the position of that train. All right, so take a look at these two guys over here. Oh, this one says, are they both trapezoidal? I don't think I meant to do that. Okay, so I'm going to change the directions on this one because I didn't want to do trapezoidal for both. Let's see here. So instead of doing a trapezoid, let's do, how about a left? We'll do a left Riemann. Okay. All right, so I wanted to practice a couple of different ones. All right, so right here, so these are the stuff up here is the same as the directions. I just copied it over so I can refer to it. Okay, so for this one right here, they want us to use a left Riemann sum, because I just changed those directions, to approximate total distance of train A. So from t equals 2 to t equals 12. So this is a little bit different. So what I do want to remind you about is when we do position, right? So let me do that down here. So our position is our initial position plus the integral from A to B of velocity, right? That's that formula. Whereas distance traveled is totally different, right? So we're not going to have an initial position. So we're just going to integrate A of B, but it's the absolute value, right? So we have to make sure that we are looking at the velocity values as all positive, right? So distance, there is no initial position, right, down here, and it needs to be absolute value, total distance traveled. Okay, so let's go ahead and do this. So we're going to be saying that our distance is equal to the integral from 2 to 12 of the absolute value of V of A of t and then dt. Okay, so when I look at and this should have said yeah, okay, so when I wrote this I should have added a few other things. So we're going to do 3 intervals as well. I just realized I didn't put that in either. Okay, so we'll do it just like we did for part C. We'll do 3 intervals, but we're going to do a left Riemann sum. Okay, all right, so our distance is going to be about equal to and then we're going to go from 2 to 12. So we're going to take a look at just this section right here from 2 to 12, and we're going to do 3 intervals, and then we're going to be doing a left Riemann sum, Okay, so we're going to start from 2 to 5 of 100, from 2 to 5, and then my velocity is 140. So then I'm going to go for left Riemann sum, so that means I'm going to use the left y values, so 100, and then times delta x, so the difference between 2 and 5 is 3. So it didn't, but if it had said the right Riemann sum, instead of 100, I would have used 40, right? So right Riemann sum, I would have used 40 instead of 100. Okay, so then let's go ahead and take a look at the next interval. So then plus, so on the next interval, this time I'm going to go from 5 to 8. So I just went from 2 to 5, so now I'm going to go from 5 to 8. And so I would have, I would do a left Riemann sum, so on the interval from 5 to 8, 40 is now my y value on the left side, so that would be 40. And then from 5 to 8, that distance is 3. And then finally, for my last interval here, so for this one, I'm going to go from 8 to 12, and I have those two y values there. So I'm going to use this next. So I'm going to use the left y value on the interval, which is negative 120, but because it is absolute value, because we are working with distance. So I don't want to use negative 120. I actually want to use positive 120. And then the distance from 8 to 12 is 4, so that delta x would be 4. And then indicate units of measure. I'm sure I forgot that on the last one. So we are working in meters per minute, but we're integrating that, so that would just be meters. Okay, and so I would group it and just say meters. And again, I don't need to simplify that, but I could, but I don't need to. And so indicate units of measure on this one too, or I guess not. Okay. All right, so for part E, so find the position of train B at t equals 3. And so for this one here, so my position, let me erase this right here so I have a little bit of room. So my position equation is equal to my initial position plus the integral from A to B of V, in this case I'm doing train B, so VB of t and then dt. No absolute value, right, because we're looking for position. Total distance, I would be using absolute value. All right, and then we're going to be doing this at t equals 3. And so that means I need to take a look at some stuff up above. So for train B, let me see here, second train. Okay, so the train B is given at this equation right here. And it starts from the origin station. So that means our initial position would be 0, right? Because we would be starting at 0. And so I need to know at t equals 3. Okay, so then I know that A is 0. So I'm starting at 0, 0 basically is what we're looking at. So this would be at, the start point would be 0, 0. So when t equals 0, my position would be 0 because I'm at the origin. Okay. So my position would be 0 plus the integral from 0 to 3. And then of the equation that was given above, so negative 5t squared plus 60t plus 25, and then dt. So it didn't just ask for the integral setup, so that means we have to do a little bit of work here in order to do this problem. So I'm going to have to integrate this, so that would be negative 5 and then t cubed over 3 plus 60t squared over 2 plus 25t, and then from 0 to 3. And then evaluate this, so I would replace t with 3, so that would be negative 5, and then 3 cubed over 3 over 3, plus, and then that's just 30, 3 squared, which is 9, or 3 squared, and then plus 25 times 3, and then all of that, and then if I replace t with 0, all of those terms would be 0. And then my indicate units of measure, so I am in meters per minute, so the integral of that, so that would just be meters. And that would be that problem. And that's it.